Welcome to this lesson on constructions. In this one we are going to talk about equilateral triangles, and we're going to talk about inscribed shapes. When we talk about equilateral triangles, those are triangles where all sides are the same, or we would say in slightly more technical language that they are all congruent to each other, and also all of the angles are the same. They're all congruent to each other. And if we know, we can expect what those angles are going to be because we know that the angles in a triangle add up to 180 degrees. There are three angles and they're all the same, so we can take 180, divide it by 3, and get 60 degrees. And we should expect when we do our construction that we end up with a triangle where every angle is 60 degrees because that's what an equilateral triangle is. When we talk about inscribed shapes, that is when one shape fits, we could say, snugly into another. So if I wanted to put a square inscribed in a circle, let's give 3 examples. And I went and drew a square and it looked like this. That square is inside that circle, but it is not fitting snugly. There's all this extra space, so that's no good. Or I could go and put a square and make it look like that. That square is too big, so that's not inscribed. But if I were to put it like this, that would be just right. So we're going to do these two things in this lesson. I'm going to demonstrate freehand over here how you do the construction. I'm going to do it formally with the compass and straight edge over here. This part goes in your notes for sure, and if you have the tools, you can also practice doing the construction on the side. So there are 2 ways to do equilateral triangle. Let's talk about the first method, which is based on copying the side. So we said all 3 sides are the same. So if you have one of the sides, in order to get the other sides, all you have to do is make copies of this. There is a triangle that I could make where one of the sides is this big, another side is this big, and this other side is this big. I'm going to create that triangle by taking my compass, pinning it to one end, opening up to this distance, and then putting that length over here. But I don't know exactly where the side is. Is it here? 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 I'm not exactly sure, so I'm going to open up and I'm going to make an arc, knowing that the side I want is somewhere over here. Then I'm going to keep my compass fixed, flip around to the other side of this segment, make the exact same arc. And when I do that, I end up with this intersection point here, which I connect to. And then I know this side is the same as this side is the same as this side. You also, instead of going up to the top above, you could have put the point down here. I could have swung my compass down, put an arc, could have swung the compass down, put an arc, and put the equilateral triangle down here. That works too. Either way you want to do it. So let's see. Here is the side that I want to use for all of the other sides. So I'm going to measure it. Swing up, because I'll put the triangle above, flip to the other side here, pin this, make the same arc. That point is important to me. One side, 2 sides, they are all congruent to each other. And we should expect to have 60-degree angles. Let's check that to make sure. Put the compass here and use the protractor part of it. So I'm centered at that angle. There's 0 degrees, 10, 20, 30, 40, 50, 60 degrees. Perfect. Method number 2 for equilateral triangles is one where we inscribe the shape in a circle. And that looks like this. We start out with some circle. Make this look centered right there. So we start out with some circle and we take our compass and we measure the radius of this circle and lock this distance. And once we have that distance, we're going to use it over and over and over to put marks all along the edge of the circle. So we're going to start out by picking any point on the edge of the circle. It doesn't matter which one you pick anything you like. I'm going to start right there. And I have my compass set to be this radius. I bring the compass over here, center the turning point there, and I make an arc. And I use that arc to put a little mark on the edge of the circle. Then I move to that mark. I use that as my new center for another mark. Then I move to that. I use that as a center for another mark. And I keep jumping from mark to mark around the edge of the circle. And if you've done this correctly, you should find that when you get to the last mark, we started here and we did 1, 2, 3, 4, 5. When you go to put the 6th mark, your compass should swing through the original point you started at. I'm going to move this over just so it looks spaced a little better. About there. Once you have these marks, you pick any 3 alternating set of marks. So I could pick this one, then I'm going to skip this mark, I'm going to go to this intersection. Then I'm going to skip this one, and I'm going to go to this intersection. I skip this one, I'm back where I started. And now I can take these intersection points, connect them, and I wind up with an equilateral triangle. And here's what that actually looks like. So I'm going to set the compass to be something like that. That looks good. Put the center. And I make a circle. If the circle has already been given to you, then you bring your compass, center it, and you adjust this to measure the circle. I don't need to do that because I just made this circle. Then I pick a point, I'll pick the same starting point, I'll go right there, and then I start jumping around the edge of the circle, making marks. So one intersection, second, third, fourth, fifth, and if we were careful and if we did this correctly, we should find that the 6th one goes right back to where we started. Looks good. I'm going to pick this point, I'm going to pick this point, and I'm going to pick this point, and I'm going to connect them to make my triangle. And then to check my work, I'm going to make sure that these angles are 60 degrees. So I'll take the protractor, center it at that vertex, adjust the 0 to be in line with the side, and there we go. That looks good. 0, 10, 20, 30, 40, 50, 60. That's a 60-degree angle. I could measure other ones. They would also be 60-degree angles. 10, 20, 30, 40, 50, 60. Good. The other thing I want to show you is that this exact same process could have created another shape for you. If we had chose to connect different points, we could have made something called a regular hexagon. And what it means to be regular is that all the sides are the same, which is to say they are all congruent. This looks identical to this. You start with a circle, you measure the radius, you start somewhere, you put the arc, you put an arc, you put an arc, you put an arc, you put an arc, you go back where you started from. But then instead of alternating, I'm going to choose all of the intersections. Because a hexagon has 6 sides. All 6 sides are the same. When I connect these intersections, I'm going to end up with this shape that has 6 sides that are all the same. And if you wanted, you could add in these other lines and see that the hexagon is actually made up of a bunch of equilateral triangles. You could think of it that way, that the hexagon has within it several equilateral triangles, or you could think of it as when you put several equilateral triangles together, you end up with a hexagon. So let's see what that looks like. I'll make this a little smaller so it fits. Center there. I'll pick that point to start. And I'm going to move the other way around the circle because it doesn't matter. One more, and I hope that when I do this last one, I go through where I started. Yep, that looks pretty good. I'm going to pick this point, this point, this point, this point, this point, and this point. And those are the ones I'm going to connect to make my regular hexagon. Perfect. And if you wanted to, you could sketch in these other lines. I'm going to just make them look very faint. And from these, you can see that the hexagon has within it several equilateral triangles, because this is the same as this, 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 because they're all radii of the circle. And then since this was the radius of the circle, and I use this distance to make this arc, that means this is also the same. And that means this is also the same, and this is also the same. And then I came over here and I put the exact same arc, so this is also the same. And then I came and put the same arc, so this is also the same, and this is also the same. And that's how we know we have 1, 2, 3, 4, 5, 6 sides, and this are all the same, and that's what makes it a regular hexagon. And the last one we're going to do right now is a square inscribed in a circle. Now there are many properties of squares that we're going to learn about when we get into our unit on quadrilaterals, but the one that we're going to focus on now is one that might not be what's most familiar to you. So when you think about a square, you think about this four-sided shape, and you think about all the sides being the same, and you also know that there are all right angles, here, 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 and here. But there's another property of squares, which is the one that's useful in our construction, which is this. If you were to connect one corner to another corner and create a diagonal. And then you take the other pair of corners and you connect them to make another diagonal. The diagonals are congruent. This is the same as this. And also, diagonals are perpendicular. And this is what's useful to us because we have this very familiar, very easy to do construction, perpendicular bisector. You remember we start with a point here and a point here. We connect them. We have this segment. We measure out more than half. We put an arc. We measure out more than half. We put an arc. Connect those, and we end up with a perpendicular bisector. That's exactly what we're going to do to put a square into a circle. We're going to start out with a circle. We're going to put any line segment across the circle passing through the center. This is a diameter. We're going to pick any one, sketch it in. Then we're going to do perpendicular bisector to this segment. So I'm going to measure out more than half, put an arc. Flip around to this side, measure out more than half, put the same arc. When I connect those, I get a perpendicular bisector. But the reason this is useful to me is because now I have these two line segments. They're perpendicular to each other. This one is a diameter. This one is a diameter. So they're the same as each other. And that means I can now connect this is not a very good looking square, but we'll use the compass and straight edge to make a good looking square. To make my square. So here it is. Start with a center point. Let's make this circle. You can put any any diameter that you want through this circle. Let's just say for some reason in a problem they told you that one of the vertices of the square had to be at that point. Okay, so I know I need to use that point to make my first diameter or my first diagonal for the square. I have this. This is the segment on which I'm going to do a perpendicular bisector. So I go to this point right here, I open up more than half, I put an arc above, I put an arc below. I flip around to the other side. I don't adjust anything. I just make the exact same arc. This point is important, this point is important. So I'm going to connect those. And now this point is on the edge of the circle. This point is on the edge of the circle. This point is on the edge of the circle. This point is on the edge of the circle. Those are the points I'm going to connect to make my square. 1, 2, third side, fourth side. And when you do this construction, it's okay if you have these little bits of pencil that come out past the circle. They're part of the construction. They're construction marks. The end result of this is that there's a square and it is inscribed, so it is sitting snugly inside the circle. If I want to check to see that I actually made a square, I'll check this property. Do I have a right angle in this corner here, in this vertex? So I'll set my protractor to be centered at that vertex. I line up the 0 with that side, 10, 20, 30, 40, 50, 60, 70, 80, 90. Yep, this is a right angle, so this was a good construction.